You're going to be watching the first screencast for the Elements of Life unit on the periodic table. So in this case, you're going to want to have a periodic table next to you to reference so you know what I'm talking about when I go over things. Now we're talking about elements, and as we know, the elements are organized into a table, and this table was designed and organized by Dmitri Mendeleev, scientist, and he organized all of the elements based on their properties. Now we're going to go through the specifics of the periodic table, which each one of these boxes means, stuff like that. So, what is shown on the periodic table? You know that each element is represented in a box. Well, what does that box tell you? You have the element name, and in this case, it's carbon. And then you have an element symbol, and these symbols are either one letter or two letters, and in any case, the first letter will always be capitalized, and the second letter will always be lowercase. So when you are writing symbols, for instance, let's say we have calcium. And if you look on your periodic table, the symbol for calcium is Ca. Now what I tend to see students doing, and which I don't want you to do, is writing the symbol with a capital C and then a capital A. Even though this capital A is smaller than the capital C, this would be incorrect. It has to be lowercase. So please be aware when you are writing your symbols what they look like, because you don't want to have to get something wrong just because you made that mistake. Okay? Moving on. What else is shown? So we've gone over the name, the element, and now we have this number here, and it's called the atomic number. This is a very special number because you're going to see on your periodic table, this is actually the number of how it's organized. If you go from left to right, you're going to see that the atomic number increases by 1 each time. So this atomic number equals the number of protons that are found in the nucleus of that element. Now it also equals the number of electrons. However, that's only if the atom is neutral, meaning it doesn't have a charge. It's not in the ion state. Atomic weight. At the bottom, it tends to have the atomic weight, and you'll see that this number is actually a decimal number. The reason being is because there are what is called an isotope, and this number is the average of all the isotopes for that element. And we're going to get into isotopes a little bit later into the unit. Now, if you look at your periodic table, there are actually 3 types of elements. You have your metals, you have your nonmetals, and you have metalloids. Okay? We're going to go over those properties. Your metals are found on the left side of the periodic table with the exception of hydrogen, and also on the very bottom. Let's think about a coin. Coins in your pockets, those are hard. Okay, we know they're made of metal, they're hard. You could actually bend your coins. It may take you a little bit of effort, but you could bend them. That means they're malleable. Malleable means they are bendable. They tend to be shiny in appearance, and they also conduct electricity. So you can see that the electricity in your house, the copper wiring, they're good conductors. They also form what are called positive ions, and we're going to get into what ions are later on. Nonmetals, found on the right side of your periodic table, tend to be your gases. Hydrogen, even though it's over here on the left, is a nonmetal. Helium, oxygen, are all found on the right side. They tend to be gases, and if they are in a solid state, they are dull looking, meaning they're not shiny, and they're brittle. They can be broken up into little pieces, and nonmetals are poor conductors of electricity. Nonmetals will form what are called negative ions. Then we have these special elements. They form a stair step on the periodic table, and these are called metalloids. And metalloids share properties of metals and nonmetals. So, for instance, they could be good conductors of electricity, however, they are brittle. or they may be dull in appearance and conduct electricity, or they may be shiny but don't conduct electricity. So they have properties of both metals and nonmetals. Now the organization, when you look at your periodic table, you're going to see that there are rows, and rows go from left to right. These rows are called periods. Okay. The elements in each period share similar electron configurations, meaning they have the same number of outer orbitals going around the nucleus. So you're going to see, if you're looking at your periodic table, there's numbers on the left side. And those numbers, 1, 2, 3, 4, 5, 6, reference how many outer electron shells they have. So everyone in period 2 have 2 outer electron rings. Everything in period 3 have 3 outer electron rings. Okay. Leading us to your columns. Your columns are called families and groups. They are organized based on similar properties. So they, for instance, everything in column 1 will form a +1 ion, a +1 ion. Everything in column 2 will form a +2 ion. Okay? They are numbered along the top of your periodic table. You're going to want to reference your other colored periodic table activity that hopefully you've already done to give you some idea of how it's organized. This is going to lead us to our periodic trends. This is basically how the periodic table is organized. It's organized on similarities and trends found within them. For instance, we just said that the rows each have the same electron configuration and that the families are organized based on similar properties. So you are going to learn more about the periodic trends doing your POGIL activities. You're going to go over the Coulombic attraction and the periodic trends POGIL activities to get a deeper understanding of the setup of the periodic table. This will conclude our screencast for today. So if you have any questions, please make sure you have them written down and come to me or your teacher in class tomorrow.